Alright, welcome back for another episode of Mr. Burley Teaches. I'm Mr. Burley, and our lesson today is about wastewater treatment and wastewater treatment plants. So we're talking about the water that goes down your drains when you flush the toilet, when you take showers, when you do your laundry, and when you wash your dishes. Where does that water go? What happens to it? How is it treated? And how does it get back into the environment clean and safe? Okay, the wastewater treatment process is pretty simple. It basically goes through 4 stages. What we call preliminary treatment is when the water actually enters the plant. It goes through primary treatment, secondary treatment, and then tertiary treatment, which I like to call disinfection. Here's a nice quick and easy image that gives you the synopsis of the process here. We're going to start with preliminary treatment with the bar screen. This is the Influent here that comes into the plant, and it has to first filter out big stuff, leaves, gloves, the trash that comes in off of the streets, things like that. We need to get all that stuff out of there. It needs to be collected and discarded. So raw sewage from sewers we call influent. That's coming from the sewers, from our houses, from the storm drains on the streets, things like that. So the bar screen is preliminary treatment. And then primary treatment, you see here, it consists of a grit chamber, a settling tank, and our solids, which we're going to call sludge. The stuff that we want to get out of there is going to actually be filtered out, go through a digester, and then down through the drying bed, basically just collecting this sludge. So in primary treatment, we're going to get this sludge out and let that just basically settle out of the influent, and then the water that continues along the line here is going to go into secondary treatment. Secondary treatment is also known as biological treatment because we're going to use biology, we're going to use microorganisms to basically clean, treat, filter the water so that it's cleaner as it moves through this process. So in order to do that, we need an aeration tank because the microorganisms that are going to be our workhorses in this process are aerobic, and they need air to live, and they're basically going to eat the phosphates and the organics and things that are in the water and basically allow that stuff to then settle out. So it's the microorganisms in secondary treatment or biological treatment that are doing all the work for us. And then at the other end, in tertiary treatment, or what I like to call disinfection, we're just going to hit it with chlorine, or maybe if it's an updated system, they can also use ultraviolet radiation. That's more or less an upgrade from chlorine. When we go to the water treatment plant, they're going to be using chlorine, which degasses pretty quickly, so it's not going to hurt anything in the environment. But the more state-of-the-art facilities are using UV radiation to zap any pathogens, anything that made it through that we don't want out into the environment. So we go from preliminary treatment to primary treatment in the settling tanks to get the solids out, and then we're going to hit it at secondary treatment or biological treatment with aerobic bacteria to basically eat the organic waste and allow that stuff to be filtered out. And then we're going to hit it with chlorine before it gets out into the environment, and we always discharge into a river, lake, or ocean. So these facilities tend to be located along stream banks, along river banks, or along the coastline. You'll always see these next to water. But that's the process in a nutshell. So let's go through it real quick. Okay, here's preliminary treatment. This is influent coming in from the sewers in our houses and things. And preliminary treatment consists of usually like a bar screen. Something like a bar screen, or what we'll see, a muffin muncher. And that bar screen is in here. It's literally just a screen that looks like this. And let's say a work glove washed into a sewer, it's going to get stuck here, or pieces of plastic or a water bottle or anything fairly large will get stuck in this bar screen, and then somebody literally has to come out and clean that off, but that stuff can't make it through the system or it's not going to work right. On the right side, this image is preliminary treatment. It's coming in, but I like this little thing here. I'm hanging from this pole. That's literally a water meter. It shoots a sound wave down to the water and it bounces back up. And what they can do is they can measure the amount of influent coming into the plant with this device. So they can monitor their flow, which changes throughout the day. If you think about it, when everybody's waking up at 6, 7 o'clock in the morning, everybody's taking showers, everybody's brushing their teeth. There's a lot more influent coming into the treatment plant in the mornings at those times. And then again, after school hours, after work hours, 5, 6 o'clock, everybody's taking a shower, they can measure the amount of influent coming in at all times of the day using the sound waves on this instrument. All right, so it's really important to know how much is coming into your plant, so you can adjust accordingly. All right, here is the bar screen. Some of those things getting stuck. As you can see, you don't want that stuff getting through the plant. Some plants might have a muffin muncher at preliminary treatment. Anything that gets through the bar screen is going to get chewed up. These are just rotating blades. So let's say a small little piece of paper or some toilet paper that didn't break up yet. It'll go through the muffin muncher and it'll literally just get shredded into tiny little micro pieces that will get settled out in primary treatment. So the wastewater plant that we're going to go visit, they have a bar screen and a muffin muncher, and you might see things getting crunched up in the muffin muncher. Okay, so after preliminary treatment, we're now ready for primary treatment, which looks like a series of settling tanks. Alright, so as the influent comes through preliminary treatment into primary treatment, it's just going to real slowly come through here, and the large stuff is going to settle, and the greases and the fats are going to float. So what we're going to be doing is allowing the sludge to settle in these settling ponds, and then we'll scrape that and clean it. But the point here is that the water moves slow enough for those solids to settle. So if you take a look at the next picture, the stuff at the top here are greases and oils. Those are going to float, and the solids are going to settle, and we're going to call that sludge. So you can literally just scrape the greases and the fats off the top. You can scrape the sludge off the bottom, and everything in the middle is our wastewater that's going to move on to secondary treatment. Here's a picture of the sludge at the bottom. If you drain the tank, which they periodically have to do, those solids accumulate at the bottom and then can then be scraped off and disposed of in a landfill. But just going back here real quick and looking at the fats and greases, this is pretty much why you never want to flush fats and greases down your drain, because it needs to be treated elsewhere. So what you can do if you cook a hamburger and you have some grease left over in the pan, instead of pouring it down your drain, just put it in like an empty coffee container, seal it up, tape it shut, and throw it right in your regular trash, because it's going to take effort and maintenance and treatment down the line. We don't want to be flushing this stuff and making it part of the problem of the wastewater treatment plant. So you can do your civic duty by throwing that right in your regular trash. Alright, now, as that middle water, we've already had the solids settle, we had the fats and the greases float, so we've separated that. The water that continues on isn't clean yet. There is a lot of organic waste still left over, and then there's also pathogens and bad bacteria that we don't want in that water. We don't want to put that into the creek. So secondary treatment is next in the process, and like I said before, I like to call this biological treatment, because it's those microorganisms, those beneficial bacteria, that's going to be cleaning the water for us. So now there's a certain way this is done, and it's called activated sludge. We're going to take some sludge from primary treatment. We're going to take some of those solids, and we're going to use them to be a vehicle to add beneficial bacteria back into the water and do the cleaning in secondary treatment for us. So if you're following along, we're putting some sludge back into the water. All right, and it will look a little dirty. It's going to look brown when we go to the treatment plant. But there's an important part here. You'll see this being mixed up, and you can see some of the bubbles here in this picture. The activated sludge, we're going to take some sludge and put some beneficial bacteria on it, but they're aerobic. They need oxygen to live. The treatment plant we're going to go to, it's a big series of rings, and what they do is they basically starve the bacteria so they get really hungry. And then they'll add some influent that has organic waste in it, and they'll eat and eat and eat. It's like Thanksgiving dinner. They just eat the heck out of it and treat the water. And then they'll starve it again, and then they'll hit it with more water that needs to be treated. So they'll do that a series of times, which then cleans the water for us. So here you go. Here are some of those guys that do all the work. So what I want you to know is that biological treatment or secondary treatment, it's the microorganisms that are added to the water through activated sludge, and it's that bacteria that does all the work. And then because we added that sludge in secondary treatment, you need to let that sludge resettle out. So we don't want that sludge in there. After the water's been treated, We're going to put it through a series of settling tanks again and allow any sludge to settle out. And now the water's been cleaned of any big stuff in preliminary treatment. It's been treated of all the solids and the fats and greases in primary treatment. It's been cleaned of the pathogens and the bad bacteria and any other organic wastes in secondary treatment. That sludge has been settled out. The water is pretty darn clean at this point. We still can't drink it, but it's pretty darn clean from when it entered as influent. The last part of the process is disinfection. The most popular and the cheapest way to do disinfection is to add chlorine to the water and then allow that chlorine to do its work. So they have what's called contact time. I think the standard is 15 minutes of contact time. So as this water travels through this maze, there's 15 minutes. It takes the water 15 minutes to get through this maze, and all the while the chlorine is having contact time with the water and any lasting bacteria before it's going to go out into the nearby creek or stream. So you need that 15 minutes of contact time to kill any lasting bacteria or pathogens that are in there. The more state-of-the-art system would be UV treatment. Not many plants have the ability or the funding to upgrade to UV treatment. However, it is out there. And that's the more state-of-the-art system to perform disinfection on treated water. Alright, to finish up here, I do want to mention what happens to the sludge. So you have this machine, and this machine is called a filter press. And hopefully the one is working at the wastewater treatment plant that we go to, because when you walk by it, this thing is pretty wild when it's operating. The filter press, if you think about it, we're collecting sludge from primary treatment. So you have a lot of sludge. Believe it or not, there's a lot of solids that settle out in the wastewater treatment process. Those solids are wet because they were in the water. Now what we're going to do is we're going to ship that either to a landfill or to a farm field or to a reclamation project in an abandoned mine. Those are three things that you can do with reclaimed sludge. However, if you're shipping wet sludge, think of carrying 2 buckets of mud. It can be really heavy, right? So it's going to take a lot of money and a lot of fossil fuels and a lot of energy to ship something that's very heavy. So what we can do is we can use the filter press to try and squeeze any water out that we possibly can to make that product lighter to ship. All right, and then it becomes cheaper on our end. So the filter press is a gigantic machine just designed to squeeze the water out of the sludge that we've collected. And when that happens, it looks like this. You get these like cakes of sludge that is then put into the back of a truck and shipped away. And here you go, they're collecting it in this dumpster. When we see it over at the treatment plant, it'll be in these like flat pancake shaped cakes of sludge that could be taken to a landfill. All right, it could be used as fertilizer on farms. But those farms, if it's used on farm fields, it can't be used for food designed for human consumption. That's the law. The wastewater treatment plant that we go to, he's having his sludge shipped toward Reading, Pennsylvania, where it's being used as fill for reclamation of an abandoned mine. So in my opinion, that's a really great use for this product, whereas you'd be using topsoil or something else. So there you go. That's a little bit about what happens to the sludge. Wastewater treatment plants are continuously monitored by not only the DEP, the Department of Environmental Protection, but also the EPA. This water needs to meet EPA clean water standards in compliance with the Clean Water Act. This water is going to be discharged to a local creek or stream, so we can't have too much untreated water going into the local stream. And if you look at this picture here, if you look at this picture here in the wood line here is probably the creek or stream where this particular plant is discharging into. So you'll always find these next to creeks or streams. I'll finish here by saying wastewater treatment plants are first world technology. All right, in the third world, in developing countries, wastewater and sewage is dealt with very differently. Here's a picture of a truck literally dumping on the side of a road or in a landfill. Sometimes they just dump right into the ocean. A lot of people believe that the solution to pollution is dilution. If you dump something into the ocean is so big that the pollution will be diluted. And we're finding out that that's not really the case. We're finding out that oceans and and water sources are all connected. Everything is connected. Always remember that. And no matter what your actions are, wherever you're dumping this stuff, it's getting into the groundwater. It's getting into our food system. In the third world, we really need to try and convince countries to put more effort, put more money and funding into proper treatment of wastewater. It is a serious problem. If you think about places like Haiti, they don't really have the money. They don't really have the options. So illegal dumping is very common. And it's one of the reasons for sickness in humans in those countries. Here's a waste lagoon next to the ocean, just an illegal dumping site. And here's a picture of some type of apartment complex, and the swimming pool in the back is actually being used as a sewage collection system. As we finish this lecture, just think about how lucky we are. And hopefully now you know a little bit more about this process. Hopefully you appreciate this type of technology and our way of life a little bit more. And hopefully in your mind the only thing that stinks is misunderstanding this technology and misunderstanding the luxury of having wastewater treatment in the first world.